let's look at an example then. This is a pitcher throwing a ball. So the pitcher is going to throw this 0.15 kilogram ball, and it's going to cross home plate. Now, notice the words are, it's completely horizontal. That's to save you from components. So keep that in mind. We're still dealing with vector quantities. So if you see anything at an angle, then we have to deal with X and Y changes. In this case, it's nice and straightforward. It's just going to go across the plate at 20 meters per second, and then the patter is going to hit it straight back. So it's like a line drive. I think that's what they're called. Back right at the pitcher, and now it has this new velocity of 22 meters per second. We want to know what the impulse is, and then we want to know what the average force was. So we might want to remind you that we've defined a change in momentum as impulse. So pause this. What I want you to do is draw a picture, and remember that these are vector quantities. So we need to define what direction is positive and negative and stick with that. And then turn the screen back on and let's see how you did. All right, so what I'm going to do is just kind of draw a small little picture here. It's going to be pretty straightforward because it's just the ball moving, and the ball is moving that way. And so I'm going to denote for myself that it's moving that way at 20 meters per second. Let's see, we'll go ahead and add in our baseball player. That kind of looks like a bat or a board. But the ball is then, he's going to hit the ball. And now this wording here, the final velocity, that means the ball is no longer in contact with the bat. That is really important to keep in mind. So this is after the bat has imparted the force that it could give. And now the ball is moving at 22 meters per second that way. It's going this direction. So here we go. Now notice I don't need to know how much time this portion takes, but I can figure out then what's happening actually at this snapshot here. Because what's happening is this 20 meters per second is going to come in contact with the bat. And the bat is going to impart a force on it that is essentially stopping it going in the one direction and turning it and sending it back from whence it came. So this change in momentum that we're looking at is going to be, this will be its final momentum, and this will be its initial momentum. So when it comes in contact with the force, it has this velocity, and just after it's leaving after contact with the force, it has that. So all of that change is happening in this amount of time. So I want to be clear about that. I've drawn the picture way far out, but let's just make sure we know where that's happening. So if I go, like, I don't know, we'll go that way as positive. Then I have, let's see, a V initial is going to be 20 meters per second. And a V final is going to be 22 meters per second. Now, for a lot of folks, you do this really quick in your heads, and you're like, okay, no problem. 22 minus 20 is 2, and that's my change, that's my impulse. And then my contact, I'm going to divide that by that time. Bada bing, bada boom, I'm done. And then you hit submit on Mastering Physics, and then you're like, wait, why? Let's see. Remember, these are unit quantities. So my V initial is positive, but what I didn't write in here is that my V final is negative. It's coming back in what I've defined as a negative direction. So when I look at a change in velocity, then that is V final minus V initial. So let's see what that is. So V final negative 22 meters per second minus 20 meters per second. So my change in momentum then, is going to be my mass times that change. So this 0.15 kilograms times negative 44 meters per second. That's my change in momentum. Now, if I want to know what the force is, remember that we've defined the change in momentum or the impulse as being force times time. So if I know the amount of time that this is happening, that this force contact is happening, then if I divide, I'm not going to do that there, then I can go, so force then is my change in momentum divided by time. So is this quantity, this 0.15 kilograms, times this negative 44 meters per second, divided by this 2 times 10 to the negative 3. If you look at this 10 to the negative 3, well, that's going to pop up top. So that's going to move this over this decimal, because it'll be positive 10 to the third, 1, 2, 3. So that's going to be 1.5, 15, 150 times 44 divided by 2. That force is massive. And it should be. I mean, you see these folks hitting these balls and they're going a huge distance, like out of the park. Well, that's a lot of force involved in that swing. So the lesson here, the take-home message I want you to have is that to change something's direction, requires a considerable amount of force. To slow something down, not so much so. But if I am going to turn it around and have it come back, then that means that I have imparted a decent amount of force. I have a larger impulse, a larger change in momentum. So what's fun to think about is the old, I'm going to throw a ball at a door because T-Rex is getting ready to come through, I don't know, or masked scary dude in a horror movie, whatever. So if you only have like a bouncy ball or a piece of clay, which one do you throw at the door to get the door to close? Well, if my piece of clay is going to stick to the door, my change in momentum would be like, let's say I throw like a baseball player. Would be, my V final is 0, my V initial would be 20, right? So my change in momentum would just be this 20 divided by the amount of time that contact took. So we're looking at the amount of time it sticks to the door. So the door's just going to kind of go, think. If my bouncy ball I throw at the door and it comes back at me, well, I have something like this. So it's a lesson in life. If you're in a horror flick or you have some sort of dinosaur chasing you, go for the bouncy ball.